Hello, welcome to the second session of the Teaching Conference 2022, our third annual online conference. This session is dedicated to active learning in person and online. I would like to remind everybody that this session will be recorded and uploaded to YouTube. You can enable live transcription, and because of the format, because it's a webinar format, during presentations, when you have questions to the presenters, please use the Q&A function and then indicate which presenter is your question directed towards. And if you see a question which you would like to know the answer to as well, like the questions, so I can identify the questions which are of kind of immediate interest. And then in case we run out of time, which if there's a lot of questions, the remaining questions will be addressed in a document that CTL will post on the site after the conference. Okay. At this stage, I would like to invite Ray to present for the paper of the right tool for the job, matching active learning techniques to learning objectives. And we're going to take a couple of questions after that presentation and then go to the next presenter.
Thank you, George. Let me share my screen first. Okay, can you all see my screen? Okay, hello everyone. I'm Ray. I'm so pleased to present some of our research results for the research project, the right tool for the job, matching active learning techniques to learning objectives. This research is conducted by Professor Sarah, Professor Luyao, and me. So this is a brief introduction to us. Professor Sarah is an economic professor from Williams College. Professor Luyao is a economics professor from Duke Kunshan University and a Sci Econ CIC. And I am a graduating class undergrad student majoring in economics from Duke Kunshan University. And I will be joining Yale University's School of Management this fall. We also would like to acknowledge Jiasheng and Tianyu for their assistance in data collection. This research is approved by the Internal Review Board at Duke Kunshan University, and this research is jointly supported by the assessment grant from the Assessment Office and the Faculty Community for Active Learning Program, Center for Teaching and Learning at Duke Kunshan University. So today I'm gonna have an overview of our research project first, and then I will go over the three main results of our research. And finally, I will conclude this presentation with the takeaways. So the first part is about the overview. Our research, titled with the right tool for the job, matching active learning techniques to learning objectives, we are centering around the idea of active learning. Throughout our research topic, we adopted the definition by Freeman 2014. And the definition is that active learning is the instruction that engages students in the process of learning through activities and or discussion in class, as opposed to passively listening to an expert. And there are several previous research has been studying active learning, and we have found that active learning techniques improve learning in university in several literature. However, many instructors make little use of active learning. we also found in previous literature that different techniques may vary in effectiveness at achieving different goals. Therefore, to further our understanding of active learning techniques and also contribute to the learning and teaching in economics classes, we come up with the following research question, which is, what are students' perceptions of a variety of active learning techniques comparatively to each other and to a set of traditional teaching methods? It's also interesting that our research has a special focus on building skills for independent research, as this kind of independent research project is not just only an important component in Duke Kunshan University's economics class, but also the graduation requirement for undergrad program where we did research. So here is a table including the 10 the 10 learning techniques that we studied in our research from A to J. So we divided these 10 learning techniques into 3 categories: traditional, active, and custom. The traditional learning techniques includes lecture, problem sets, quizzes, exams, written reflection, and research idea presentation. So as the name represents, these are relatively more traditional and more daily used learning techniques we used to have. And the second category is called active learning techniques, including small group discussion, debate, and peer advice. And another category is called custom learning techniques, which are specific to our research project, contains Python simulation and game. Python simulation are just economic simulation of some economic class samples in a language of Python. So it's kind of a combination of computer science, programming, and traditional economic modeling. So we also have the corresponding grading weight and the rules in the table. We have introduced the research question, the 10 learning activities. But how are we gonna collect the data? We actually designed a survey and delivered it to the student body after the course ended. And in the survey, we asked the students like mainly four types of questions. First, how actively they engaged with each technique. Second, how much they enjoyed each. Third, how effective they felt each was at achieving each of a set of learning outcomes. And last, which was most useful in developing their independent research project. And accordingly, we have 2 hypotheses. So first, we hypothesize that students engage with and enjoy the active techniques more. We also hypothesize that higher grade weights may also make them engage more actively. So in a short word, the more active, the more engaging. And the other main hypothesis is that different techniques will be effective at achieving different learning outcomes. For example, for the techniques that offer an instructor more control, such as lecture, quizzes, exams, and problem sets, we hypothesize that these kind of techniques are more effective in helping students remember specific concepts. And for techniques that allow more voices to be heard, like presentation, peer advice, small group discussion, and debate, we think they might be effective in understanding different perspectives. So here is a data overview of the research result. We have the 10 learning techniques listed on the y-axis, and we have the engagement and 6 different learning outcomes listed horizontally. And this number are the reported engagement and learning outcome effectiveness. The first column is about the engagement level, and these are the reported effectiveness toward different learning outcomes for each learning techniques. So let's discuss about the first main result. The first main result is about engagement and enjoyment. Through our hypothesis testing and correlation calculation, we found that how actively a student said they engaged with a technique and how effective they felt it was at achieving each learning objective were strongly correlated. So this is a box plot about the enjoyment level for across the 10 different learning techniques. So we can tell from the graph that students enjoy game the most and peer advice the least. We also found that enjoyment is not broadly correlated with learning objectives through our hypothesis testing. In fact, the activities that students gave the lowest enjoyment rankings to were also the ones that show some correlation between enjoyment and learning objectives. In other words, only for those activities that are enjoyed the least, those unpopular activities are actually have like the stronger correlation between enjoyment and learning objectives. But in the same time, we also surprisingly found that enjoyment and engagement are almost uncorrelated. And now let's talk about the second main result. The second main result is about matching active learning techniques to learning objectives. We found that written reflection and especially the peer advised assignment are most commonly ranked as least effective techniques. Besides, we also found lecture, problem sets, and quizzes exams are reported to be quite effective for many outcomes and are the best for memorization of concepts. However, for some innovative techniques, which have a clear link to some outcomes, they are especially effective toward these outcomes. Let me raise some example, like research idea presentation. They are effective in helping students analyze real-world issues. And discussion and debate, intuitively as they are effective for collaborative learning. And debate is effective for understanding pros and cons of macroeconomic policy. And now let's go over the third main result. The third main result is about the independent research that we have mentioned. So again, this is a box plot about the effectiveness level across different learning techniques. We found that lecture and the research idea presentation are relatively effective for this outcome. Python simulation is rated as significantly more effective than some other techniques. This is very interesting because the Python is still not often being included in economic education, but in this research, we found it is significantly more effective than many of the techniques. We also found that peer-advised assignment is rated as significantly less effective than most techniques. And in the end, in the last question of our survey, we asked the students to brief upon the class components that they think effective, they think useful in helping them complete their independent research project. And we compiled their answers to this word cloud. You can see there are multiple words in this graph, and actually the size of each word represents how often the frequency of the words being mentioned in the answers. So we can tell that research and Python are mentioned the most frequent words, and they are followed by concept, question, presentation, think, debate, these words. And we can briefly conclude that the word cloud is actually congruent with the result in the previous slide. So the last part is about the takeaways. We are delighted to see that most of the results are actually support our hypothesis. Like the first hypothesis, the more active, the more engaging. Our data mostly support our first hypothesis. And we also found active learning techniques do vary in their focus and mechanics, and thus are most effective at different objectives. Therefore, we would encourage instructors to use a mix of different learning techniques to maximize the effectiveness towards different learning objectives, and kind of stimulate students' engagement. However, we also have some unexpected results. So first, we observed that lecture is perceived as particularly helpful for most of the outcomes, including learning to do research. But peer advice assignment is rated relatively low on most objectives. So we would suggest instructors in the future to be more cautious about peer advice wide assignment. Even though we have these great results, but we do recognize our research has some limitations. So first, we have a relatively small sample size. And second, our data source is basically self-reported responses instead of objective measures such as just like grades. And also, it's important to mention that any technique's effectiveness for any outcome will depend on implementation. But even though these limitations exist, we still believe that our research have already provided some insights into understanding the active learning and their effectiveness, and it could provide some helpful advice for instructors to design their economic course by borrowing some ideas from our research. Thank you for watching this presentation.
All right, thank you, Ray. There's multiple questions in the Q&A, so I'm going to direct them in the order. Please, all the participants, remember to ask questions from the Q&A, and also if you see a question that kind of overlaps or you just want to know the answer to, you can like the questions. So the first questions based on what we see is from Carlos Cortinas. Ray, when you say a technique is effective for a specific outcome, what do you mean? These are self-reported data, right? Did you relate this data with actual performance? So do you have any measures of performance you could put this together?
So I don't know whether, do you want me to hop in, Ray?
Yeah.
Okay.
Sure.
I forgot what we decided about which of us was going to be answering questions versus whether it was all of us. Hi, I'm Sarah. I'm one of the co-authors on the paper. So a number of the questions in the chat point to this. I'm sorry, in the Q&A point to this, and we appreciate the comment. I mean, basically the question is, are we looking at just self-reports, or are we looking at actual performance that is quote unquote objective? And for this study, we are looking at a relatively small sample. We're looking at 28 respondents, and we're looking at self-reports about these outcomes, these learning objectives. We thought in this case that it would be helpful to look at what subjects thought on, somewhat more subtle measures. We weren't sure we would be able to measure, sort of substantial changes in performance on, say, an exam or something, especially because a lot of things that we're interested in are a little bit more subtle here. So it's not what you would call objective, externally validated measures, but we think informative nevertheless, as long as it's taken with a grain of salt.
Okay. Hopefully that answers the question. I think Doug has an overlapping question again on the same level of whether how well do you, but I kind of will add to this is how well do you think students recognize what's effective? Do you think students like, so this is the part of a question, which is the overlay. Yeah. No, so again, that is, so there are two issues with self-reports, right? One is how honest are they? And two is how accurate are their perceptions? And I think we're not trying to claim too much. We are being clear that these are the students' perceptions. If there was going to be a big bias there based on students thinking something is more effective than it really is, you would think that enjoyment would drive more measures of effectiveness, and that's not what we see at all. So, you would think that people would think, oh, like, the game is so much fun, it's the best thing at everything, and that's not actually what we're seeing. So, while there is some danger there, we think that it seems like students are being quite thoughtful. I will answer one more. I will have you answer one more question, and then we'll do the rest of them at the end after all the presentations have finished. So there's a question from Stephen Proud. Is it really a surprise that lectures are seen as effective, as these are the norm? Often students in academics are very conservative, and because delivery lectures are the norm, and because they're easier to engage with, they could be thought of as effective as a result.
Yeah, I think that that's totally reasonable. It wasn't what we went in expecting. We're expecting to say like active learning is the best at everything. But I think that that is quite reasonable. I think, my experience as an instructor, students like it when the professor will stand up there a minute and explain some stuff. And so I think from a lot of our lived experiences, it's not super surprising, and there may also be that behavioral element that it's what students are accustomed to. So I think that that's a perfectly reasonable, if anybody has any references on that, we would love to find sources we could cite on that, because that it seems to be the case. Okay,
thank you. Thank you, Sarah. Next we have Zach Goodman, and I will let him take the floor.
Thanks, George, and thanks to the conference organizers for putting together such a wonderful conference. Thanks, Ray, for that presentation. It was super interesting. I want to go ahead and share my screen. I'll start a slideshow here. All right, we all good? Everybody can see my screen? Very excited to share with you some results from work with my co-author, Melissa, who's in our virtual audience today. We are going to tell you about a technology called the Intermediate Microeconomic Video Handbook, and the results from an experiment we ran to try to get an estimate of what the effects are of this technology. I want to start by sharing a real anecdote from Melissa's office hours. This was back in about 2014. A student came in and said to Melissa, "I'm having some trouble in your class. I'm not doing so well. What could I do to try to do a little bit better in your class?" And Melissa said, "Well, have you been doing the course readings?" And the student scoffed and said, "Read the textbook? You expect me to read the textbook?" In other words, there's no way I'm going to read this textbook. It's boring. It's not engaging. This is the tech generation. We're not reading textbooks anymore. And that was sort of Melissa's aha moment. So at office hours that day, the instructor had the aha moment, not the student. And the aha moment was that maybe for a generation that has had unprecedented access to media and YouTube and all these technologies, a classic textbook is maybe just not the best way to transmit information to students. And so the department, led by Melissa, created this technology called the Intermediate Microeconomics Video Handbook, or the IMVH for short. It tracks what a textbook might cover, but it is entirely videos. And there's 220 videos total. It encompasses the complete 3/4 sequence of courses that we give at UCSD for intermediate microeconomics. Each video is about 10 minutes or so in length, and it covers everything from theory to application problems. So it's a pretty wide range of videos. And so far, we've had about 100,000 views per year. And this is available at all the UCs and a couple other universities that have licensed the technology. I also want to point out that a lot of care went into organizing the videos in such a way that information is very easy to find. So every video is located within a topic, which you can see on the left side is broken down into different subtopics. And then each of these has several videos which provide descriptions of where in the video you can find core information. So it's a little bit faster to find stuff than, say, flipping through a textbook. There's also a search feature that allows you to get to stuff fairly quickly, and you can search for content within the video itself as well. So thinking about why this technology might work better than a conventional textbook, it shares a lot of features that other existing high-tech learning technologies have, like recorded lectures and e-textbooks, and actually has some additional ones that maybe the individual ones don't have themselves. So for example, while recorded lectures and e-textbooks can be accessed anywhere, and the marginal cost of these technologies is basically zero, e-textbooks can be searchable, but most recorded lectures aren't searchable, which might make it kind of hard for a student to find the specific place in the lecture they're trying to get information. And while a recorded lecture doesn't take much energy to just sit back and watch something, and might be a little bit easier for some students to get over that initial hump, the IMVH does have that. And so there's some advantages that it shares across these other technologies. But we also want to say that the IMVH is not really a lecture replacement. We actually see it more as a lecture complement. So while the IMVH we think is closer to a substitute for an e-textbook, it's more of a complement with lecture, where students can get live feedback and can also learn from their peers who are in the same classroom as them. So where did we test this? We wanted to learn what is the effect of this. We're all scientists. We want to make sure that this technology works if we're going to be sharing it with so many students. We tested this at UC San Diego. A couple interesting features of this class, just to make sure that we understand where these results are internally valid, and we don't want to take a leap and say this will work everywhere. So you might need to retest this at your university if it looks a little bit different. At UCSD, Intermediate Microeconomics is a 3-course sequence. The first course where we tested this is mostly sophomores, and it's about 1/3 transfer students. And most of these students haven't yet declared a major, but most will end up going on to economics or another tangential major. For this experiment, we ran it over 4 classes, which each have about 200 students. So these are pretty large lecture classes. And we only included students who scored below the median on the first midterm in the experiment. And the rationale there is that we didn't know if this technology would work or not. So we didn't want to burden the high-performing students by taking away from their existing learning technologies that they're using. We didn't want to force on them to use the IMVH, because goodness knows if it didn't work, that might do some harm to those students. So we only ran this experiment on the subset of students who scored below the median on the first midterm, which is about 400 students. Let me tell you about the experiment. We used an encouragement design, and this is more of an ethics choice than anything. It would have been a little uneasy to say only half the students could have access to this new technology that we developed. So rather than restricting access, we induced greater take-up of these videos using a grade scheme. And the way it worked is after the first midterm, we assigned students to treatment or control. In the treatment arm, students received 4 percentage points towards their final grade by watching at least 40 videos. and it's all or nothing. So if you watch 39 videos, you didn't get the 4%, but if you watched all the videos, you get as much credit as watching exactly 40. There were 48 total incentivized videos. To get that 4%, we reduced the weight of the first midterm. And that's a really key feature of this experiment because we did not affect any of the remaining points left in the class going forward. And by doing that, there's no additional incentive to study harder or study differently to try to get more points going forward towards the final. So all of the incentive to watch videos is from this exogenous 4% and not something endogenous about getting a higher grade on one of the upcoming exams. Our sample size has about 400 students and it's 200 per arm. We announced when or where students were, if they're in the treatment arm or the control arm, just after the drop deadline. And by doing that, we made sure that our sample was pretty solid. And then we could observe outcomes both at the second midterm and also at the final exam. And the cutoff to watch the 40 videos was a couple days ahead of the final exam. Okay, so first thing I want to show you is that the first stage was super significant and that the encouragement worked. And I want to tell you, it was not obvious to us that this would work. 4%, at least to me, did not seem like that much of an incentive. But as you can see in this plot, it did get the treated students to watch a lot more videos than did the control students. So we saw a very large increase in video watching as a condition of receiving this incentive. I also want to show you that students were paying attention to which videos were the incentivized videos and which ones were not. So on the right panel of this plot, you can see that there's a large separation between the students who were incentivized and those who weren't by video. Whereas on the left side, these videos did not count towards the 40 videos that you had to get the incentive. However, these videos were relevant to the first midterm and the final exam. And so there could have been some additional motivation to watch videos, having learned that this technology might have been useful to you. So we do see a slight statistically significant increase in video watching for the unincentivized videos, but you can see the magnitude is not nearly as large as it is for the incentivized videos. And in total, the incentivized students watched about 60% more videos, and that translates to about 6 hours of content or about 3.5 hours of unique content. So this is not a huge burden on the students either. It translates to about an hour of content more per week. So a student who's very actively watching these videos would spend about an hour more per week studying if they didn't reduce any of their other studying concurrently. Okay, let me show you one more plot about the first stage. I also want to show you that students were watching videos relevant to the exams at a time that made sense. So in the top plot, you can see when students were watching videos relevant to the second midterm, which is this dashed line here. And what you see is before the experiment starts, there's no separation at all in video watching between the treated students, the control students, or the students above the median who aren't in the experiment. But as soon as the experiment starts, you can see the red line, the treated line start to separate. And this is only for videos that are relevant to that second midterm, which takes place 3 weeks after the experiment starts. You can also see that that spike continues going into the final exam. And that makes sense because the final exam is comprehensive. So students should be watching videos relevant to the second midterm. And then the bottom plot, these are videos that are relevant to the final, but not the first or second midterm. And you can see a slight increase here, but we're not really statistically significantly different there. But going into the final, you do see a separation that is statistically meaningful. Okay, so students watch more videos that they're treated. They watch videos that were relevant to the incentive, and they watch videos that are relevant to the exams. So now the question is, did it make a difference, or did we just waste the time of our students? And fortunately, we did find positive effects and pretty large effects, actually, especially when you consider how much time this was. So the reduced form, what is the effect of being treated? We found that being treated increased exam scores both on the midterm, second midterm, and the final by about 0.18 standard deviations. And in our class, that translates to about 1 step. So going from, say, a C- to a C. This translates to also about 6 hours max of work required. So as far as a policy goes, this was only about 6 weeks or so of class, an hour per week, in order to raise grades from a C- to a C. That seems like a pretty large effect for not that much additional work. On a per video basis, we found that the returns to the second midterm were a lot larger than the returns to the final. So for the second midterm, we found that 1 hour of content raised scores by 0.16 standard deviations. And for the final, it raised scores by 0.05 standard deviations. And we think the reason why the returns were so much larger for the second midterm compared to the final is that a lot of students waited until the last week to watch the bulk of their videos to hit that 40. And by doing so, we think that watered down some of the effectiveness of the videos. And so what that tells us is if we were to rerun this experiment, it might make sense to offer intermediate deadlines rather than one deadline right before the final exam to try to get over that binge watching behavior for a subset of students. We looked at scores on the exams as a function of what their first midterm score was, and we didn't find anything statistically meaningful. We're not really powered to say anything strongly here, but suggestive evidence, it looks like the effects are pretty even across the distribution for the second midterm. And for the final, there's this little bump towards the bottom third of the class that looks a little bit larger than the next bit of the class distribution. But again, we're not really powered to say to say anything statistically meaningful here. If you look at the y-axes, these are pretty large y-axes. These are standard deviations. So we're going from -3 to +3 standard deviations. So pretty large confidence bands here. We also looked at whether or not there was contamination on other study methods. By encouraging take-up of videos, did we reduce studying elsewhere? And we didn't find anything here that was statistically significant. Directionally, it looks like our discussion board got a lot more activity as a function of being treated, and attendance went down very slightly. But again, nothing here is statistically significant, so I wouldn't read too much into this. We also looked at grades in other classes. These are classes that were taken in the same quarter. And again, we don't find anything statistically significant, but if you look at the confidence bands here, we can rule out large negative effects. So in other words, the additional time required to spend in the class where we ran this experiment, it doesn't seem to have had very large negative effects on other courses. And that's true regardless if we look at just econ courses excluding the current course, or all of the courses excluding the current course. It doesn't matter if you look at the number of classes passed, the number withdrawn. The only negative number here, and again, this is effectively 0, is probability of taking the current grade for a letter, as opposed to say pass-fail. The other really interesting thing that we found is looking at what happened the following quarter. And the following quarter, a lot of the students went on to take the second course in a 3-course sequence. And the video handbook still works in the sequence. It works for all 3 of the courses. So in this course, there's no longer a direct grade incentive to watch videos. There's no, you get 4% if you watch more than 40 videos in this class. But we did find that treated students continued to watch more videos than did the control students. And that tells us something about mechanism here, where maybe students learned a bit about the video technology that they didn't know before, and maybe updated their priors that this is a useful learning technology, or they got used to using it, and they continue to use it even in the next course. This is not a huge effect. It is statistically significant, but it's not a, in my opinion, a very large effect. And unsurprisingly, we don't see any effect on exam scores. We do see a very slight, marginally significant negative effect on continuing on to the next course. So I think this is more of adding hypotheses for future experiments, but we think this raises a question of, did we update priors on students' preferences to continue in economics? Did we give our students a more accurate representation of what's required to succeed in these courses, which are pretty tough and are regarded as among the harder courses in the economics major? I'll show you one more slide. We think in the paper talk a little bit about some models of student behavior, and we try to fit our results within these models and try to see if some of the implications of these models make sense given our results. And we start by talking about the neoclassical rational model, where students are strategic in how they study. They know the returns to studying, they have perfect information, and forcing on them an incentive structure like the one we had might actually reduce utility, because now you're forcing them to spend more time studying and they would rather be doing something else, either studying with a different technology or perhaps spending time with friends or working. And we found, we find that this model is probably unlikely, especially the complete information part. And the reason for that is we don't think we would have seen persistent take up of these videos in the second course in the sequence when there's no exogenous incentives. That doesn't line up with that model. We also talk about a behavioral model where students might procrastinate, and by assigning them some additional points to study earlier or to study at all, you might induce more studying than would happen otherwise, and the planner self of that student might be better off. And we do think there could be some truth here. And as I already mentioned, we think more frequent intermediate deadlines might end up improving long-term outcomes and might line up better with what that planner sees for themselves. Anyhow, there's a lot more in the paper, so I do encourage you to check it out. I put a QR code here following what one of our panelists did at a previous seminar last week for the asynchronous ones. I thought that was kind of clever. And my email's here if you have any questions or would like to contact me. And also happy to answer questions via the Q&A feature. Thanks.
Thank you, Zach. We have some, it's an exciting paper. We have some questions coming from both the panelists and the Q&A. So I could think it's a fairly quick question. So Claudia asked whether, like, why would you guys develop your own resource versus using something existing like Modular Evolution University?
That's a great question. I think Melissa would actually be better to answer this because she was there when this started. I became a graduate student at UCSD shortly after development of this technology. If I'm not mistaken, I don't know if these resources were as common 7 years ago as they are now. So part of it might have been availability. Part of it also might be the ability to customize towards the level that was appropriate for these students. And part of it also is this technology is available across all UCs. So spreading that cost, the fixed cost of development across that larger population ends up being fairly small. And then the marginal cost is effectively zero. Because once it's in the cloud, it's there and doesn't cost much to share.
Thank you. I think everybody, there's two questions which have massive overlap from Patricia Toledo and from Simon Halliday. So the general gist of it is, how do you know when that students watch a video, not just click the video? Can you define watch video? Like, what is your definition of it? Like, is it hit to play, or is it watch to the end, or some other proportion, watching 75%? And also, one could have a treatment that answer a question about the content of the video and demonstrate understanding to count as watch at the end. And it probably, but though it probably would cut down how many students would want to do that.
Yeah, that's a great question. I should have addressed that in my presentation. We have a pretty sophisticated backend that tracks actions on the video platform. And fortunately, we were able to use that to both get data to do the analysis, but also to provide feedback to the students about how many videos they've watched. There's a couple things we did that were kind of cool. One is we tried to look at, I should say, the platform does not record how long a student is active on a video. And that's a problem because we don't observe actual, like, your eyes were on the screen actively watching. We can observe hours of content and how many things were opened. But one thing we can do is we can look at timestamps between when videos start. And so one kind of clever thing we did during the experiment is provide feedback to students based on time between these videos. And a very small handful of students opened 45 videos all at the same time and watched 45 videos all at once. And so in a span of less than an hour, watched 7 hours of content. And we provided feedback to the students and said, based on our algorithm, we identified this as not watching. So please actually watch the videos to receive your 4 percentage points of credit. I think if we were going to do this again, it'd be really cool to get some measure of like mouse behavior in a video or some sort of interactive component in the video to make sure that students are actually paying attention actively on there. This is probably something that is beyond scope for an academic setting, but I do know some of the tech companies have technology that goes on the top of your laptop and can watch your eyes, and they can track eye tracking on a video. So for the very, very high tech future, maybe that's something that's within scope.
Fantastic. Thank you for that. That is a very sophisticated system. This is really neat. One of the questions which got upvoted is from Doug McKee, and I'm very curious if your institutional review board had any issues with the experiment. In particular, assume they felt it was fair to give half a class a different gradient scheme.
Yeah, so we went through IRB, and one of the conditions that IRB required is that when we curved the class, we had to curve independently the treatment arm and the control arm. And so the way we did this functionally is apply the curve to only the control arm, which includes both below and above the median scores, and then adjust the curve for the treatment students so that their average and the average in the below median control group end up being the same. And what that gets you is X post fairness between the two arms. And that way, if the videos were harmful or helpful, you end up with the same average grade in those two arms. Now that we know the videos work, I think the right thing to do would be to apply a similar incentive structure across the entire class.
That is neat. That is neat. Like very clean design. And so the last question I will direct to you, and then we'll leave the rest of the questions into for the remainder for the final question period, is coming from Sarah Jacobson, and she's wondering whether you found any heterogeneity by gender. Basically, if you have a statistical power, like what other dimensions of demographics can you see? Have you tried it?
We did try. We unfortunately are underpowered, especially when you control for multiple hypothesis testing. Directionally, there was not a large effect for gender. We found a directionally large effect for Asian students. We did not find a directionally large heterogeneous effect for transfer students, which surprised us. And we also, we could observe visa status, and we did not find a large heterogeneous effect for international students, which also surprised us. So we predefined a couple heterogeneity variables that we cared about and did not find anything on those. And then when you put the full slate, you do find a couple stars. But again, once you control for testing multiple hypotheses, those stars go away.
Fantastic. Thank you so much.
Thank you.
I think, Alex, you're up next. So.
Yep. Okay. Thank you. And thank you to Ray and Zach for their presentations. Just going to share my screen. No. So yeah, just wanted to say thank you to everybody involved in the organization of this conference. It's been a really insightful few sessions. So my name's Alex. I'm a teaching focused lecturer at the University of Manchester. And today I'm presenting some work called Promoting Student Lecturer Interactions in Large Lectures. This perhaps isn't as involved as the previous two presentations, and is maybe a little bit more of like an easy win to try and gain some more interaction in sort of a more traditional setting. So this isn't the most innovative, creative work. I'm going to sort of preempt a lot of those sort of thoughts, but it is something relatively straightforward to implement that perhaps even the most difficult lecturer could be convinced to do, let's say. So essentially the premise of this is to introduce another member of staff alongside a traditional sort of chalk and talk lecturer who is able to answer and respond to student questions, so clarifying questions concurrently, and thus not breaking up the flow of the lecture content. So this is something that we implemented to sort of solve a problem, but then I think it also has some wider benefits. So I'm going to kind of give the context of this, if I can click through. So this was done at the University of Manchester. We're a very large university, and our economics course is also very large. And it was done in a first year microeconomic principles lecture. So when I say a large lecture in the title. We have over 1,000 students in this course. So it's a very big course. And then obviously because of COVID, we had to do this hybrid. So due to travel restrictions and various other reasons, we had a large percentage of our students who were unable to make it to Manchester. And so we had to deal with these two different groups concurrently, which, as you can imagine, with such large student numbers, can create some issues. So, as I said, it's a very large module, over 1,000 students. They're roughly all similar in terms of previous grades, and they're split into two separate streams. That was basically just because we didn't have a big enough room for all of them at the same time. I'm just going to refer to them as stream A and B throughout this talk. It comes up now and again. But yeah, essentially identical between the two streams. And this was sort of a traditional, in quotes, face-to-face lecture. Still lots of interaction, some polling, interactive elements, asking the students questions. But a lot of the content delivery was just done in the sort of traditional way. But obviously this year, with this hybrid element with a lot of students on Zoom. So there was roughly 550 students in each stream, and I'd say about 100 in each stream were online, to give you an idea of those percentages. So kind of the initial thought process was these online students are going to be somewhat abandoned if we're not careful. Okay, so if they're on Zoom and it's a traditional face-to-face lecture, they need to have some way of engaging with the lecturer and to be asking questions, even just general tech support. So this was really the core issue. And yeah, they need to ask questions of the lecturer. And so what we basically did was use some Q&A software, which is Slido. So I'm not sort of wedded to Slido. It's just some online Q&A software. It's very basic. This isn't like a promotion of Slido or anything like that. There's lots of other Q&A softwares, which I'm sure could work just as well, if not better. But yeah, this is just an example of it. So essentially, there was a problem, which was it's very difficult for one lecturer to deal with both the remote and in-person students. And what we did created a wider benefit because the adaptation or the adaptation of using a second member of staff in the lecture also benefited the in-person students. So it's really this second point that I'm going to be talking about more, because this is where I feel like there's some potential for it to be used and implemented in future. So to kind of give more of a background, the traditional sort of, I guess we're all interested in teaching here, and I'm sure most of us have asked this question: does anybody have any questions to our students? We kind of all know it's not the best question to ask because generally you get tumbleweed. Students are very averse to speaking up in class and very averse to showing a lack of knowledge. Okay, so this isn't great because if students have questions, we want them to ask them. We want to know what needs clarifying, where they're struggling, and if we can explain something again or in more detail to help them. Now, if you have 500 or 600 students in your lecture and the students were very honest with you and did ask every single question and you were on your own, then you've got sort of the exact opposite problem that you'd never get any lecturing done. So if you're committed to that sort of traditional content delivery by standing up and delivering the content, you'd never get any course content done because you were just dealing with students' questions. So what did we do to kind of allow students to ask questions, but not interrupt the course content delivery too much? Well, essentially, it was just the traditional lecturer at the front delivering the content, and then we added me. So I was the lecturer assistant in this first year microeconomic principles course, and I was just sat at the side on my laptop. I didn't do any content delivery. I didn't really speak to the class at all, but I was just there at the side, and the students were aware that if they had any questions, they could ask them of me. Right? And that was true for both the in-person and the remote students. Okay. So this is essentially what Slido looks like. This is, again, I'm not wedded to this piece of software, but this just gives a kind of indicator of the sort of questions that the students were asking. So one great thing about it is that it's anonymous, and that kind of overcomes a lot of the nervousness and the barrier to asking a question with students not wanting to show a lack of knowledge. So the fact that it was anonymous meant that students were freely able to ask a question, and there would be no sort of embarrassment about that. And we can see from this, just within 14 minutes, we've had 3 questions. Okay, so this isn't actually in chronological order. I've just randomly chosen one of the Q&As that we had for this, and you can see that it's all sort of course content related, asking about marginal, why is there no profit in this extreme case, etc. And then I was able to answer those questions without interrupting the flow of the main lecture. Okay. So, as I said, students are able to ask questions on this. They're able to upvote questions they want answering, and I was able to also respond with multiple responses. You know, if I didn't do a very good job the first time, I was able to have another go and try and explain something in more detail. So essentially, the idea is to allow any student an opportunity, a relatively easy and sort of free opportunity to clarify their thoughts, to allow more engagement within the lecture, so that if they're stuck on anything, they're just able to have that clarified super quick, and then the rest of the lecture they can pay attention to. There's no sort of stumbling block where, you know, 10 minutes in, they don't understand anything, and then they switch off for the remaining 40 minutes. This just allowed them to properly engage with the entire lecture, because anything they didn't understand, they were actually able to ask. Now, the question is, did they use it? And I think the next slide is kind of the sort of the selling point of using this method with the second lecturer on the Q&A, is that we had quite a huge number of questions, in my opinion. So over the course of the semester, we had a total of 425 questions asked by students. So if you think about a normal lecture series and the number of times that a student would put their hand up to ask a question, I mean, over the 2 courses, it's obviously averaged out over 210 questions. It would be impossible to ever see 210 questions asked over 15 lectures, in my opinion, and it would be very difficult for one lecturer on their own to be able to answer all of those without it interrupting the content delivery. So you can see there's a couple of spikes. Lecture 5, for whatever reason, might have been somewhat confusing to group A or group B, sorry. Yeah, but in general, usually about 10 or so questions asked per lecture. In terms of course content, I do have that data. So I think it was like roughly 60 to 70% of questions were clarifying questions. We did also have other sort of comments, things where they were sort of just saying, I'm confused on this, rather than asking a direct question, which in itself is insightful. But yeah, the vast majority of them were in fact just asking, can you explain this to me? And I was rapidly typing at the side of that classroom. I think lecture 5 especially was a very busy time for me. So for use in future, you might be wondering, well, was it just all the online students who were already set up? They had their laptops in front of them, and were they just the ones that were asking all of these questions, and it wasn't addressing anybody in class? So unfortunately, from the Slido data, we weren't able to kind of get that information from it, but we were able to survey them at the end. So we asked all the students to complete a survey asking a few questions on different aspects of the course, one of them to do with Slido. So we had over 300 students surveyed in total. I kind of grouped them into the people who were always online and always in person. We had a few who were sort of between because there was a hybrid option. So the always in person people on average viewed the Slido 6.5 lectures out of the 15, and all 100 of them on average asked a question during the semester. Okay, so if you think about an average student in your class, it would be very rare, I'd say, to have a question from, on average, every student during that semester. So I think this is a fairly sort of significant increase in the amount of engagement that they're having. The online students, of course, as expected, asked more. So yeah, they asked 2.7 questions and viewed the Slido more on average, kind of, yeah, as expected. These, of course, are just self-reported, and there's kind of no way to verify that they're telling the truth, but that's just student survey evidence, I guess. And then we asked them if they found it useful. So whether they found me sat at the side answering all those questions useful or not. So the red outline in this is the online students, the gray is the in-person students. So again, these two same groups. So generally everybody finding it at least a little useful or moderately useful. Again, the online students finding it more useful. That ties in with the fact that they've used it more. But kind of on its own, this doesn't really tell you much. So we did ask them basically the same question, which was like, how would you rate the usefulness of this? So the usefulness of Slido, and then we also asked them the usefulness of the discussion board that we used. So if you use discussion boards, and especially with 1,000 students, the amount of time that you put into answering questions on discussion boards is fairly significant. And we can see that although students sort of on average are saying that they're more useful than the Q&A in the Slido, it's not a massive difference between this. So sort of one of the main selling points for me with the use of this Q&A and the Slido software is that it was sort of very little effort in a lot of ways. So it was just me in the lecture room at the side, and very sort of little discussion between me and the main lecturer on how to go about this. So I was kind of willingly thrown in at the deep end and figured it out myself. But all it took was just, you know, the time actually in the lecture to deal with the questions that were being asked. And I just answered them concurrently, and then that was it. So you think about the effort that you need for discussion boards, you know, the discussion boards obviously useful, more useful than this, but students seem to still like this Q&A software. And it also really came up in the course unit evaluations that this was something that students appreciated. So just kind of highlighted the bits that really indicated that what the students were getting out of it was what I was thinking that they were getting out of it, which was this clarifying things, the fact that I was answering most of the questions, and yeah, any doubts that the students had were cleared instantly, and that allowed them to remain focused. So again, to kind of go back to that point of students losing engagement in lectures because they don't understand something, but then they're not willing to ask a question and then just kind of abandon ship a little bit. This is a super simple way of just allowing them to re-engage if they do have any doubts. So that's sort of the student use and student thoughts. So I was obviously relatively busy during those sessions, so this is my thoughts. So if you are ever going to run hybrid lectures, I would really recommend this. It was especially beneficial, I think, to the online students. And in terms of their feeling part of the community, I think it was really good that they kind of ended up having their own lecturer. So some of the comments on the Q&A sort of near the end of term started to ask me like, oh, Alex, how was your weekend? And that kind of thing. So it really built a little online community that I had with them, which was really nice. So if you're doing hybrid lectures, I would 100% recommend. For in-person, so solely in-person lectures, I think this is a relatively low cost. Obviously, you need another member of staff, which isn't always the least costly element. But in terms of like adapting to different modules, you can essentially just drop another member of staff in relatively simply. And it's easy to trial for the first few lectures. So you can see how it goes for 3-4 lectures. If students aren't using it, you can see that that's a sign that it's not useful within that specific module. And I think because it's so little sort of cost to adapt this, it's not a huge thing. It's just another member of staff on a laptop with some software. It's easy to recommend to other lectures. One thing that might have happened is that the in-person students might have been encouraged by remote students. So if you were to do this just in a solely in-person module, the take-up might not have been so great. But one thing that I do think was really good, so I was kind of reflecting on my own experience lecturing. So I'm very early on in my career, and I found it immensely beneficial to be a lecturer assistant and sort of be in that lecture room with all the students, but not in the role of lecturer. So, if you have a graduate teaching assistant or a teaching associate that you think could take this role, I think it would be very beneficial to them. Just in sort of developing that practice with actually being in a lecturer room, yeah, I think it's very beneficial to them. Just a few very final thoughts on the last slide. So this is something that I'm going to trial in future in an all-person lecture. That's something that I'm going to do in September. This is very non-committal. It might be more or less suitable for more quantitative courses. I'm teaching a maths course in September. Going to see if it actually works with that. And then might be less effective, kind of expecting it to be a little less effective because it's just in-person students. But obviously, as the title of this says, this is for large lectures. And so really depends on the course size. So if you've got 30 students, I'm not recommending you do this. This is more for those big sort of scary lectures where students don't want to speak up because they've got another 600 students in front of them. And I think that's my time up. And so I'm going to end there. So thank you very much. Yeah, and I think we've got some questions from George.
Yes, so there's quite a bit of interest on what happens with the, first of all, thank you for your presentation. This is an interesting intervention. And as you said, relatively low cost. So I think there's an interest of what happens to the Q&A file on Slido. So do students have access to the Q&A session after it ends so they can use it for future reference?
Yes, so they do still have use of the Q&A, I believe. I can't really see them actually. So they can go back onto it, but I don't think that we actually spent a lot of time sort of promoting that, which is something that we should probably have done. Yeah, so we had that, and we had the discussion boards sort of running concurrently, which was in itself something that we considered maybe might cause some issues, that there were two avenues for students to ask questions, and perhaps some of the live questions really should have been on the discussion board to then look back on. So now and again with the questions, I did sort of say to them, this in fact is a better question for the discussion board. Could you upload it to there? A lot of the time, the things that they were asking were just small sort of, what does KL mean? What does this mean? So we're sort of better to be done within that time period. But yeah, it probably would have been better if they had the link sort of in perpetuity forever. Yeah.
Okay. Thank you. And also, so there's similar questions on the lines of what do you observe with the students? For example, there's a question from Carlos Corfinas. Did students keep engaged with the ongoing lecture, or did some students start to read the ongoing Q&A and fall behind? So, like, what is was the pace of the lecture slow, or so to allow the students to dip in and out of the Q&A session?
Yeah, that's a good question. So unfortunately, it's not really something that we could observe. So obviously with online students, yeah, we just weren't sure. None of the students had their cameras on or anything like that, so you couldn't really see if they remained focused. In terms of the in-person students, you know, as I'm sure most people are familiar with in that, a lot of them were still on their laptops. So you don't know whether they're looking at the Q&A, whether they're looking at the notes, or whether they're just on Twitter. So yeah, it's really kind of impossible to answer that. We didn't slow down the lecture to sort of allow for this Q&A thing to be looked at. But as I said, it was an interactive lecture, so there were times for polling and things like that. So at that point, you know, students had that little bit of breather where they could check the Q&A. But yeah, in general, I kind of don't really have an answer to that, unfortunately.
I'll just have a follow-up from Claudia on this one, linked to this question. So so besides students getting distracted, do you think the lecturer can get distracted by the Q&A at all?
So
I mean, I understand you're handling that kind of on the side.
Yeah. So I don't think yeah, I don't think that was really an issue. I think there was sort of a trust that I could handle that Q&A. And then there was also an agreement that if there was anything specifically interesting, or like something that I felt everybody needed to know, that I would then interrupt and say to the main lecturer, could you sort of explain this to everybody in the room? So it kind of really wasn't handled by the main lecturer. It was just me. So there was no distraction really within that, I think.
Okay. There's another question following up on this, and then I think I'll ask questions to a few questions at directed at our presenters. So did you consider that the main lecture stop every, say, maybe 10 minutes and go through the questions on Slido or Padlet or something else? There would be less resource intensive and potentially more engaging for the students. But
okay, so yeah, so a 10-minute sort of deliver content and then pause, and then yeah. We hadn't considered that. No, that is definitely something that I can imagine being effective. I guess, as I said, this really was sort of set up as a way of just ensuring that the online students were or had some sort of access to a lecturer and could ask questions. So that was how it was implemented, and that was how it was kept throughout the semester. I'm sure that could be a very effective way of teaching, and yeah, of having that sort of broken up time to go through those questions. But yeah, that's not something that we sort of thought about, but something that I could implement in future.
Fantastic. There are a lot of really great questions in the Q&A, and I really wish I could just direct them all to you. But I would remind everybody that there will be a document with the answers to these questions posted on the by CTAL. And so I actually have a question for Ray and Sarah and Luyao. So when it comes to the Python simulation you've mentioned, do students participate by submitting responsive, some strategy choice, or are they led through a coding or a simulation?
So this is a Python simulation that that Luyao had. This is in Luyao's class, so she had set it up in advance to simulate the economy and different parameters in the economy. And I apologize, Luyao had to run for another event, so I'm speaking on her behalf here. And so students were walked through an exercise where they were going into the Python code. So the Python code existed. They went in and they modified the Python code to simulate different things in the economy. And they basically watched how the simulation worked. So they were sort of not coding from the ground up, but they were modifying the code and watching the outcome.
Okay. And question, with regards to what's happening in the classroom, was how much does the instructor explain to the students, this from Doug, why they were using different methods? Like this could have been a big impact on students' engagement and their perception of effectiveness.
Yeah, it's a good question, and it's a question I don't have the answer to. I actually shot Luyao an email. Ray, I don't know if you have any thoughts about this, but I don't have the answer to it. It's definitely something we need to address.
Okay. I know that there were multiple questions directed at Zach. Zach has answered some of them online, but I would kind of want to come back to this because I think some of the answers are really fascinating. So there was a question of like, this was first of all positive comment. So this is what a great example of using modern econometric methods to do economic education research. And so when you have this experiment, Zach, what was the F statistic of the first stage?
Yeah, I actually had to look this up in the paper because I didn't remember exactly what the F statistic was. But I remember, like, off the cuff, it was higher than 10. So you check the box for the rule of thumb. And then there's a Stock and Hugo paper that say, actually, 10 is probably not good enough. You should maybe try to hit at least 16. And we did hit that for both the second midterm and the final. When I looked up the paper, it was around 18 for the second midterm, and it was over 100 for the final. The reason it was so much larger is that the deadline was right before the final, and so students watched a lot more videos going into that exam.
Okay, and the other question is from Victoria Jotham. So do you have to worry about regression to the mean as an alternative explanation, especially in the light of the absence of positive grade effects in the next quarter?
Yeah, so I think this comment is a good point, which is that students who score below the median on the first midterm maybe score above the median in subsequent exams. And that's true. The predictive value of the first midterm is something like 0.3 is the correlation coefficient from the first midterm to the second midterm. That said, the experiment is entirely below the mean, below the median for the first midterm. So we're comparing apples to apples. So if there is a regression to the mean, that's okay because your treatment group and your control group both would experience that same regression to the mean.
Excellent. So one I bring up, thank you so much. That's really cool. So Alexander, I have a question for you. And it's more of a, I guess, comment. There's plenty of students, you mentioned like using this large versus big classes. So there's a comment that plenty of students in small classes are still afraid to speak up and might be willing to type their questions, especially if anonymous, something to consider.
Yeah, definitely. It kind of, I think my point with that was more, you know, if you're in a small class, then maybe you don't need the sort of assistant to cover that quite so much. So yeah, if you're in a class of 30, it could be something that, you know, the main lecturer could handle on their own in that case. This was sort of really pitched at large lecturers because, you know, as I showed in some of those statistics, had up to 40 questions in some lectures, and that you can't deal with on your own. That's where a second person sort of has to come in.
Yeah. And we have a question for you would be, were remote students too involved in a way that makes it very hard to answer questions? From Stefan Lamy. How do you deal with very high numbers of questions during a short session, like of an hour?
Yeah, yeah, effectively, yes. I mean, I wouldn't say they were too involved. It's great that they were asking questions, and it shows that they're engaged. But yeah, there were a few hours where I was very busy. But you know, generally, a few of the questions would be on similar stuff, so you could kind of copy and paste answers, that kind of thing. You'd get flurries of questions here and there. But yeah, generally it was not too bad. More or less, it was spread over the time. I think because all the students have access to every other student's questions, they could usually then see that it had been asked or answered, and then not sort of, it kind of reduce the need to repeat it for me. But yeah, there was a few heavier sessions, but yeah, generally not too bad.
Okay, fantastic. Thank you so much. Well, given the time, first of all, I wanted to thank all the presenters for fantastic, really interesting research in econ ed, especially active learning. It's from very different angles. This is exciting, and I believe that there's more exciting presentations to come. Up next, we have a session of new ideas and assessments in feedback, and there should have been a link, which I believe the link should be posted in the chat to that session. Fantastic. I want to thank Mahaiming for fantastic support. They're great. This is the UCL student support, making sure that everything runs smoothly. And please don't forget that after this, there will be a mixer run by the Royal Economic Society, focusing on, there will be elements on the job market, job search in the UK, in the US, and also there's also opportunity to continue the conversation about active learning in the Just Chat section. So thank you everybody for coming here. Thank you for being a part of this session. Have a fantastic day.